Okay, so we've dealt with palettes and the palette handler. Obviously, the most important command we need to think about is get a new class. The grab sprite handler. Okay, so again, like all the other handlers, this is a command handler. We'll have our public bool override bool is valid. Checking, and we will need our public override run. Now, if we remember that on our script here, grab sprite, we can pass various options. We always need to pass in at least 2. If we don't pass, which is the name and the type. If we don't pass in 2, then we need to pass in 6. So we go back to our grab sprite handler. We now need to say, so if get num arguments is not equal to 2, and see get num arguments is not equal to 6. So if it's not equal to 2, it's not equal to 6, then we know there's a problem. Now, the first one's easy. First argument is easy, it's just a plain string, but our second argument, now we've got, at the moment, we've got these options. We may want to have more at a later date. In fact, I'm sure we will want to. So we need a way of validating what we're passing in and also knowing what they are. So rather than just have a lot of string compares, what I'm going to do is I'll create an enum for them. So I'll have options unknown in case you've passed in something invalid. One option we've got is data. We've got a mask. We've got the mask and then the data. And just in case you want it the other way around, data and then the mask. So they're the main options we need at the moment. And what we'll do is we will have a dictionary, which will be a string and an E option. Helps if you spell string right. We can preset this one, we don't need to configure it, so we want, this is the name that we're going to check for, and then what we'll do is, in our case, this one will be option data. Okay, we'll have one for mask. Mask. We'll have mask data and data mask. Mask underscore data and data underscore mask. So there are options that we're interested in. Now we've got those, what we'll quickly do is we'll write a function, we'll make it private, which will return the option from a string. Option from string. Let's make it uppercase just in case we haven't. And then we can just say if option type types contains key. So we're checking if the option is in our string. If it is, we can just return the enum. Otherwise, what we'll return is eOptions unknown. So this is just a function that allows us to pass in a string and it will tell us if it's one of our valid options. So in here, what we now want to do is go if get option from string, it's always going to be argument 2. Is equal to eOptions unknown. So if we don't know what it is, it's invalid. And then the only other thing we need to check is if we're passing in 6 arguments, if sc, let's check they're all integers. So is argument 2 an integer? So sorry, if argument 2 is not an integer, if argument 3 is not, these are the x, y width heights if we're passing them in. So that'll do our validation. I've had to turn the heater on, hopefully the noise isn't too much on the mic. So now what we need to do is actually grab the data. Let's write some defaults. Oh, we've got the working palette, we haven't got the working image. So we'll add a couple of functions to get the size. Because obviously if we're not passing in any parameters, then we're using the entire image. Let's go and add those now. So we added our get working palette. What we can do is go public int get working image width. We could just return the actual bitmap itself. I'm going to try and, because I know we're going to, at some point, I'm going to want to change this to do a bit more work. I'm going to put them as functions. The advantage of putting in functions is if we at a later date want to change it from a bitmap, we only have to change these functions. We don't have to go into lots and lots of different places and change how we get information. It's always useful if you can keep changes into as limited places as possible. Obviously, we need to check if it's null. Current image. Okay, so we can get the current image width and height. Here we can read the size of the image. If we're passing in 6, then x will be get integer, get argument as integer 2, y w h that'll be 2, 3, 4, 5. We could also actually probably say if x is less than 0 or x is greater than get working image width, or y is less than 0, or you got get working image height. I'll do this another if. Obviously the dimensions are wrong, they go outside, and same as if x plus w is less than 0, or x plus w is greater than ed.work get working image width, y plus the height. Again, a lot of times you could get away without putting any of these sort of sanity checking in, but old habits. So that'll verify that. We then need to work out what the format is. So let's get the format option. So e options equals get options from string, and we'll do sc.get arguments a string. So we know what format we're trying to do this in. One thing we didn't do, which I could probably do. Grabbing sprite. Let's just say what sprite we're grabbing, just so we know what's going on if we're looking at the output. Okay, so we've got the format and everything. One thing we're going to need is we've got our SAM palette that does all this. We are going to need somewhere to store the sprites, so let's quickly add another class here. We'll call that SAM Sprite. There's not much to this class really. Zero private height equals 0. Oops. This is by far not the most efficient way to do it, but we are using. This is usually for older machines. I certainly wouldn't do this if I was, as this was converted for like Xboxes and PlayStation 5s and things, but using a list to store bytes probably isn't the most efficient. But it makes the tool a lot easier for us. And as most of the data we're going to be converting is quite small, let's go with ease. Every sprite's got a width and a height. What we're going to need some functions. Get width, int get width. I'm sure we're going to need to know what the width is at some point. Can't spell today. We're also going to need a function called, let's call it add data. That's simply going to add that byte of data to the sprite. In our export class, very similar to the sprites, to the palettes. Dictionary string SAM sprite. And then let's add it to the reset while we think about it. Sprites clear. Then we had some functions here for adding and checking sprites per palette, so we're going to need the same thing for sprites. So it has sprite, sprites, SAM sprite, get sprite, sprites. And that should probably, I think that'll probably be all the functions we need. Find out in a minute. Okay, so what we now need to do is so we can add a sprite, get argument a string, and when we add a sprite, unlike the palette, we need to say what size the sprite is. So pass the width and height. We could double check, say if sprite is equal to null, return false. Can't imagine it'll ever happen. Now this sprite will be based on the working palette, because the working palette is the one that we pulled from the image that we're also going to pull the sprite from. So, and we'll need this to get the color numbers. So let's get a working palette as well. Now we want to run through all the pixels. So we're going to go from y, yp is less than y plus h. And similar on x, except with the SamCap, obviously this, again, I'm only doing mode 4, we can add in other modes at a later date. We do 2 pixels at a time, so here we'll do xp plus equals 2. Now, as you know, if we compare, there is another function we need. So that's a function we'll need to add. What we need to do is pull in the 2 pixel colors that we're going to do, in this case xp and xp plus 1. So if we go back to our export data, have a public returning an RGB value. We want a function that allows us to pass in an x and a y and get the appropriate pixel color. So this is straightforward. If the current image is null, we will return an alphaed out image. We will just double check because the function before is doing 2 pixels, and we may only have an image that's an odd number of pixels. If we just check if the x and y are in range. So for outside of the range, what we'll do is, again, we'll return a color. It's not ideal in some ways. Really, you should check the source data is the right size. This will return alpha images. So for sprites, it'll be fine. If you're using the mask data, because it will automatically mask it out. Return the pixel. So we just want a current image, get pixel. So it's not ideal. We could maybe put something in to do range checks instead. But for now, again, let's just get this working. So we've got our pixels. Let's actually we'll store these as bytes because that's what we're going to have to use. So we've got the bytes for data. We've got no graphics, and we'll calculate the mask. We've got no masks. What we need to do is check if the first pixel is transparent. So if alpha is not equal to 255, we consider it transparent. And we may set up some options for this. I'm using the lovely bright pink as transparent. So if it's either bright pink or there is alpha, this is the first pixel, so we'll set the mask to F. To say we would want to keep the background. If it's not, what we actually want to do is get the colour we need. Now we've got our working palette and we've already written, I think, closest. We can get a SAM colour, but that gives us our entire SAM range. That's okay. Well, let's get the rest of this written. We'll see where we are. So we'll get the closest SAM from RGB. Shifted up 4 because it's in the upper nibble. Effectively, we now want the same for P2. We'll shift that up. We'll sort out the function we need there in a moment. We'll just finish writing this bit. So if we go through, so if we want just the data, we just add the data byte. If it's the mask, we ask the mask byte. If it's the mask, then data. We do the mask, then data. If it's data, mask. Right, so that will go through every pixel and write out the right data in the right order. So let's just have a look at Sprite. This goes through. We effectively want this function again. This one finds the get SAM from RGB gives us a SAM color from the full 128 range. We want the closest one in our current entries. So it's not, this one won't be static. So we only want to look at the palette entries we've got. So we read our SAM color out the palette entries we've got, get its RGB, and we'll return the SAM index color for that. So that should be everything that's needed. Oh. Got a comma. Some missing brackets. Oh, missing bracket there. Won't need that bracket there. Oh, and of course, one I always forget. The handler for it. And if we just stick a breakpoint in here just to check it, should be everything we need to grab a sprite. Oh, should be one. So we're coming in, we're grabbing a sprite. The first one in the script is grabbing data for the entire image. So there's the data, the width and height it's got. The first pixel, if we look at the image we're doing, as you can see, most of the first row is transparent, so it's going to say it's transparent, and it's going to mask in the mask. So we actually got if we stick a breakpoint here just to check, we want 255. We want black, so that would be. I think the first colour will come out as black. Yep. So it's going to return that one. So yes, that seems. And if we come down, stick a breakpoint in here to make sure it gets all the way through. Seems to be stuck in a loop somewhere. Ah. You can see that I'm doing this live as I've got mistakes in it. Right, now this sprite, the image we're grabbing is 58 by 49. My maths is not good, so when it comes to things like that, so 58 divided by 2, because 2 pixels times 49, actually I could have probably worked that out by hand, 1421 bytes should be what we're storing in our sprite. And there it is, there's the information. So hopefully, if we run all that through, it should all be good. So that grabs all of our sprite data, which really leaves one last part for the main chunk, which will be to write out to this function here to write out everything as ASM, which actually is quite straightforward. Should only take about another half an hour to do, and so in only a few hours we've created a basic tool. We'll add some more of the functionality in that we've got further down to write out single things, and start looking at some other bits and pieces with index palettes. But yeah, shows how easy it can be to write a tool like this. Yeah, I'll hopefully try and get the next part up in a day or so to do the output.